In this video, we are going to discuss about kinematic equations for uniformly accelerated motion. Once again, kinematics. Kinematic equations for uniformly accelerated motion. Here, actually there are two methods are there. One is non-calculus method, second one is calculus method. Now here we are going to discuss about non-calculus method. The method is also important. Once again, today our concept is kinematic equations for uniformly accelerated motion. Here there are two types of the methods. One is non-calculus method. The second one is calculus method. Calculus method means integration method. Now, how many equations of motions? There are 4 equations of motions. That is V is equal V naught plus AT, or we also write it as V is equal U plus AT. Now second one, S is equal V naught T plus 1 by 2 A T square, or S is equal UT plus half A T square. Now point number 3, V square minus V naught square is equal to 2AS, or V square minus U square is equal to 2AS. Fourth one, yes, nth is equal to V naught plus A by 2 into 2n minus 1, or S nth is equal U plus A by 2 into 2n minus 1. Once again, I am repeating the 4. Here V is equal V naught plus AT. V is equal to final velocity. V naught is equal to initial velocity. A is equal to acceleration. T is equal to time. Similarly, V is equal to final velocity. U is equal to initial velocity. A is equal to acceleration. T is equal to time. Second equation of motion. S is equal to position or distance. V naught is equal to initial velocity. Small t is equal to at any instantaneous of the time. A is equal to acceleration due to gravity. Small t is equal to time. S is equal to position or distance. U is equal to initial velocity. T is equal to time. A is equal to acceleration due to acceleration. Of is a constant. A is acceleration. T is at any T is time. V is equal to final velocity. V naught is equal to initial velocity. A is equal to acceleration. S is equal to displacement. Similarly, V is equal to final velocity. U is equal to initial velocity. A is equal to acceleration. S is equal to distance. S is equal to distance or position. V naught is equal to initial velocity. A is equal to acceleration 2n minus 1, where n is equal to distance travelled in nth second. Sn is equal to distance. U is equal to initial velocity. A is equal to acceleration. N is equal to the distance travelled in n seconds. Now, these are the 4 equations of motion. Now, I would like to explain one by one. Please observe carefully. Now, we are going to discuss about the first equation of motion. The first equation of motion, or the another name is velocity time relation. Now, here we also call as V is equal to U plus AT, and also we called as V is equal to V naught plus AT. My dear students, in the examination, out of this, he will ask any one. So, we have to write the same answer. Now, take here O, it is X, consider 2 points. This is here X naught, here is X. It is at a 0, it is at t. Consider it is X. Now, what is the difference between these two, this X and this X? I can explain. It is at a point or at an initial point, the position is X naught, the initial velocity is V naught. At a point t, the position is X, the velocity is V, and this is up to and so on. This is up to and so on, called as X. That means total from 0 to X. Okay, in between, this is starting point, this is ending point. In between, we are discussing or we are observing a vehicle is started here. At the time, we are calculated time is equal to, consider as 0. After some time, the time we can consider as t. Initially, its displacement is equal to x naught. After that, its displacement is x or position. Initially, its velocity is equal to v naught. After some time x, t, its velocity is equal to v. Now go for discussion. Consider an object moving with constant acceleration along positive direction of x axis. Once again I am repeating the point, my dear students. Consider an object moving with constant acceleration along positive x direction of x axis. Consider 0, it is positive x axis. Consider positive x axis. Now here x naught is equal to position of the object at instant small t is equal to 0. Now x is equal to position of the object at instant small t. Once again I am repeating the point, my dear students. X naught is equal to position of the object at instant small t is equal to 0. X is equal to position of the object at instant small t. Now v naught is equal to velocity of the object at instant small t is equal to 0. Now v is equal to velocity of the object at instant at instant cap small t. Once again, v naught is equal to velocity of the object at instant small t is equal to 0. V is equal to velocity of the object at instant small t. Therefore, velocity after a certain time, velocity after a certain time is equal to acceleration is equal to change in velocity whole by time taken. Once again I am repeating the point, my dear students. Acceleration is equal to change in velocity by time taken. Therefore, acceleration is equal to v minus v naught whole by t minus 0. Therefore, a is equal to v minus v naught whole by small t. Therefore, at is equal to v minus v naught. Therefore, v minus v naught is equal to at. V is equal to v naught plus at. Consider equation number 1. This is called first equation of motion or velocity time relation. Okay, this is called first equation of motion or velocity time relation. Now, v is equal to velocity t is equal to time. Therefore, this first equation of motion we also called as velocity time relation. Now, go for one numerical. A race car accelerates on a straight road. On a straight road from rest to a speed of 180 kilometer per hour in 25 seconds. Then find its final velocity. Question mark. Now, what the examiner given? Now, what the examiner given? The examiner given a race car accelerate on a straight road. Here, in the 25 seconds, then find its acceleration. Once again, I am repeating the question. A race car accelerates on a straight road from rest to a speed of 180 kilometers per hour in 25 seconds. Then find its acceleration. This is the question. Now what the examiner given? The examiner given initial velocity is equal to 0. Now final velocity v is equal to 180 kilometer per hour, that is equal to 180 into 5 by 18 meter per second, that is equal to how much? 50 meter per second. Given time is equal to 25 seconds. Now, what is acceleration? This is the question. Okay. Now go for solution. Now, solution. Here, the acceleration A is equal to, what is the formula? V minus U by T. Now acceleration A is equal to, what is V final velocity? Final velocity is equal to, we got 50 and initial velocity is equal to 0 whole by, what is time? The time is equal to 25 seconds. Therefore, the acceleration is equal to how much? 2 meter per second square. Like that, we have to solve the any type of the numericals. My dear students, I hope you understood what is the first equation of motion, what type of the numericals the examiner will ask. However, thank you very much for watching this video.